We first defined even and odd functions geometrically. Now let's revisit them with an algebraic point of view. We defined that a function y equals f of x is called even if it remains the same when we reflect across the y-axis. F of x equals x squared was our most studied example of an even function. We more recently saw that the graph of y equals f of negative x is the graph of y equals f of x reflected across the y-axis. So since the graph of y equals f of x reflected across the y-axis is the graph of y equals f of negative x, and this must be the same as the graph of f of x, putting these together, we can conclude that a function y equals f of x is even if f of negative x, the reflection, equals f of x, the original function. This gives us an algebraic way to check a geometric concept. So let's check algebraically if f of x equals x squared is even. That is, let's see if f of negative x equals f of x. For this function, f of negative x is negative x squared, which is negative x times negative x. But if we multiply two negative numbers together, we get something positive, and this is just x squared, which is f of x. So we can conclude that f of negative x equals f of x for the function f of x equals x squared. So by our algebraic definition, f of x is an even function.